Today, let's go through the owl pellet lab. So the owl pellet lab has very simple procedures. You just need an owl pellet. And if you have these, you can use these. Kids enjoy them, but they're not necessary. Little hand lenses. They sometimes use these. Most of the time they tear them apart with their hands. Gloves. Now gloves, you may disagree with me on this, but the owl pellets are sterile, and so they don't really necessarily need gloves. I actually have them as a choice, so I have boxes out. Half of my students use them and half of them don't, because they actually watch a video up here, this YouTube link, where the guy is dissecting without gloves on, and they think that's kind of cool. So it's up to you, and you may disagree with me philosophically and safety-wise. That's okay. You can provide gloves for the students. Now, owl pellets are expensive, but it gives them a hands-on way to work with food webs. So this is what I do to save costs. So in my lab, and by the way, you really want large. They're more expensive, but I did the cheaper ones for many years, and really it's better with large. Unfortunately, they do cost more. So the large can be $2.50 to $3 per pellet, which adds up if you have a lot of kids. So I have lab tables with 4 kids. So this is how I save money. An owl pellet can really only be done by 2 students at a time. It's just not big enough really to have more people hands-on. So this is the owl pellet. So in their groups of 4, I have 2 people dissecting the owl pellet and 2 people doing eco column data. So we do data about once a week, and their eco columns have been going on for several weeks at this point, or at least 2 weeks by the time we do owl pellets. And so for the first 30 minutes of the period, now, eco column data, once they're trained, really only takes about 15 minutes of class time. But on this day, I give them 30 because I have 2 people doing the data. And normally I have 4 people doing eco column data. And then I have 2 people doing owl pellet dissection. And I let them split it up. Some kids don't have any desire at all to touch the owl pellet, and so they are perfectly willing to do the eco column data. After 30 minutes, they should be done with their owl pellet, and all of them will work on the data analysis together, which is the hard part of this lab. So you could have them work on paper towels. If you have dissection trays, you can have them do that. If you have paper plates, you can have them dissect on paper plates. So I have 45 groups of APE students in groups of 4. And so these can be expensive. The reason why I split them up is because if I'm paying $3 a pellet, times 40 to 45 groups, that's still about $100 if that's one per group. If I did it 1 per pair, that would be $200. Which is too much money. I don't have that kind of budget to spend on one lab. So this is why I do it this way. Okay, so with the owl pellet, and I'm gonna go ahead and put on gloves just because I prefer them, but again, if you don't have them at home, that's fine. It's really your choice. Hey, you can even put on any kind of glove that you want. It doesn't have to be latex gloves. Or these are vinyl actually. We can't use latex in our school anymore because of allergies. We had a student once who couldn't even be in the same room as latex. Her throat would close up, and the school couldn't use balloons that year. So latex allergies can be real serious. Okay, so the biggest thing that they want to do is, we're not concerned about being very delicate. We are more concerned about counting the prey. We're not IDing all the bones. We are only counting the prey in here. And we mostly do that through skulls. So I just found a skull. I'm going to tell you 99.9% of everything that students find is going to be rats or mice mostly rats. And this, I can already tell, is a rat skull. That's a pretty big rat. It's juvenile. You can get bigger ones than this, but this is a nice big rat skull right here. So we know we have one prey at least. This is probably the hip bone from the rat skull. And so we're really trying to count skulls in here, but on occasion, sometimes kids don't find skulls. They find the other bones, and I guess the skulls end up in a different owl pellet. So, here's more hip bones. There's another hip bone right there. So that's at least another animal, because every animal has 2 hip bones, and then that's part of a hip bone. Oh, and there's part of another skull. So that's a smaller rat right here in here. Over time, you'll get better as a teacher helping kids identify the bones inside the pellet. All right, so I'm not going to do the whole thing for you. So at home, you probably have an owl pellet delivered to you. So you can go ahead and take it apart. You see, I can use my fingers. If you don't have tweezers or any other tools, it's okay. It doesn't really matter. What we are concerned about here is counting the prey. And so you also have these reference sheets with you. And I've labeled them for students. They have a kind of a hard time. So they have a hard time between mouse and rat, especially baby rats. So I give them a ruler too. The mouse skulls are very tiny. They're a centimeter or less. Rats are bigger. And so sometimes I come over, I'm like, what'd you find? And they're like, we found 3 mice. I said, did you measure them? Well, no, they're small. And they measure them and they're 1.5 centimeters. And so I'm like, well, that's a rat. Oh, so this one you can see we're measuring the length of the skull, and I'm estimating where the skull would be around the back. And so this is definitely a rat. Okay, also, let's say you found 1 skull, but you found 3 hip bones. You have 2 animals in here. And if they have a hip bone and they're like, well, this hip bone looks more like a shrew, I'm going to tell you right now, and I tell my students, I'm like, we have never found a shrew or a mole. I'm like, if you think you have one, you don't. The only way you're going to know if you have a shrew or a mole is by the skull. And the students always want to be the first kid ever to find a shrew or mole in my classes. Now, you may have had better luck. You found these things, but we never have. So we found birds, and we found mainly rats, sometimes mice. Birds are more rare. Sometimes you can find a bird. And so if they find just hip bones, they're going to hold this up and they're like, well, this looks very much to me like a shrew hip bone. It's not. It's going to be a rat hip bone. Also, sometimes they think that a bird's, the back here, they think that that is a bird, but it's actually the back of the rat skull, because this picture doesn't show it rounded, and I don't have a good example, but it's actually very rounded, the lobe back there. And it's usually a rat back of the head. Okay. So if they don't have skulls, or they don't have all the skulls, they can also identify the number by how many per animal. So I've altered this before I Xerox it for the students. They are mostly going to use this page. I also give them some more reference sheets here. This one shows the back of that rat skull a little bit better with the rounded. Here's some more rodent, and then here's the bird one. So the bird one is kind of interesting. A lot of times you'll see the claws down here. That's kind of fun. Sometimes you'll have this huge, I don't know what parts of the bird these are, but really interesting bones if you happen to get a bird. Okay, so let's talk about data. That's the hardest part of this lab, is the data analysis, but it's the most important part of the lab, and it makes it worthwhile. You need to hurry up your students unless you have more time in APES than I usually do. Let's say you have a double period or whatever, but Some students are done in 10 minutes. Some students, you go by them after 20 minutes and they've done hardly anything because, hey, they're very surgical and very precise and they want to get everything perfectly out of here, which is what they might have done in elementary school. Because in elementary school, I think if they do these, or junior high, they spend a couple of days getting all the bones and identifying them. And you can do that if you want. I just don't have the time. So I hurry them up because I say we are just counting prey. We are not worried about IDing all the bones. It's not an anatomy class. That's not our important focus. Okay. Have them read the introduction. They especially need that number later on. These two videos are good to watch ahead of time as our engage. All right, so what the typical data will be 2 rats. That's a very common data. They don't need to know the length, it's just there, but they don't need to know it. And I am actually not going to walk you through rats, so if this video makes it somewhere on the internet and your kids have this data down that I'm going to do for you right now, you'll know they cheated. All right, so I'm going to actually do this for 1 mole and 1 shrew because your students, I am 99.99999% sure they will never have that data. And then they fill in zeros for the ones that they don't have. And so remind kids that that zeros are okay on here. If they don't find it, it is a 0. Okay, number eaten per day. So this number here, about 2.5 pellets per day on average. So we're going to multiply this number times 2.5. And so we're going to get 2.5, 2.5. And then per week, so 2.5 times 7 is 17.5. So go ahead and follow along with the data that you got from your owl pellet today. Pause the video, finish your dissecting, count your prey. And if you feel like you're a little bit off or you don't know, show it to me on a next Zoom call and we will take a look at if you are unsure of what a bone is. I will do my best. I'm not the expert, but I've done it for over 10 years, so I have some experience. Okay, and so then the number eaten per year, a lot of kids don't remember that there's 52 weeks in a year. So we want 17.5 times 52 weeks in a year, and we have 910. And then we're going to add these up. And we're going to get 1820. Okay, so that's our total number of prey per year. Now you go ahead and do it for the prey that you got in your owl pellet. So every group should be different. They all have different data from their own owl pellets. So if their data is, you've got half the class that has the same data, you'll know that they copied off of one person. Okay, next, we're going to use data to help analyze the amount of biomass food needed at trophic levels to support your owl. Create a numbers pyramid based on the number eaten per year with 1 owl at the top and the total annual number of prey below. Use the assumption that an owl produces an average of 2.5 pellets per day. Well, we already got that number. It's right here. So we can just put that here. Okay, that's a lot. You can talk to your kids that that's actually quite a lot. Okay, next. Oh, by the way, we are outside during quarantine in my backyard and you can hear a batting cage in the background. One of my neighbors has a batting cage, so they practice. Or actually, I think students come, I think he's a coach, and students come over to practice in the batting cage. Okay. Or tutoring or something, I don't know. Anyway, it's a batting cage, lots of batting going on. All right, so prey. Let's draw a food web that is representative of your pellet. So This is what the prey eats. So there's a couple of things you can do. Most of the time I've had students, and I have to start it with them because food webs they're not very good at it. You would think they're good at it after studying them in 7th grade and 9th grade, but they're really not. So I have to begin it with them. So we have our owl up here. And what did we find in the owl pellet? What prey did we find? We found a shrew. We found a mole in our owl pellet. So you could do it a couple of ways. You could have them do, and this is what I normally do, I have them make their food web just on what they find in their owl pellet, or you could have them sketch out all of this, so all the prey an owl eats. All right, but I'm gonna show you just using what's found in the owl pellet. So we're gonna look at a mole. So these are the species, kind of, they're not really species, they're categories of animals or plants. And tell the kids this, tell them that in apes, we want to use specific species most of the time for a food web. But for today, we're going to use just a category of species. So we have earthworms. The mole eats earthworms. It eats centipedes, millipedes, snails, slugs, grubs. They sometimes don't know what some of these things are, and that's okay. You can teach them. Ants, bugs, termites, beetles, crickets. Okay, and so all these things go to the mole. So it's the direction energy comes. Sometimes I make it funny. I say, like Austin Powers, get in my belly. So the beetles are going into the belly of the mole. Okay. But that doesn't work on an AP test. They have to say it's the direction of energy. All right, so now the shrew. Beetles, I already have beetles. So I can put beetles over to the shrew too. Okay. Oh, I made a mistake. Did I? What did I do? No, I didn't. Okay, so beetles we already had here. We also have it here. Oh, grasshoppers is new. So I'm gonna put grasshoppers. And I like it when some of the species are the same for both of them. And that way you can see the more of a web. So I have grasshoppers, butterfly and moth larva, which you don't have to put larva. It's actually just butterfly is one. Moths are not the same. Okay, etc. So I'm not going to draw the whole thing out. So list all of these. And you're going to have a big old food web here. If students only have like the rat, most students are going to end up with a rat or two. Seeds, nuts, grains, vegetables, fruit are all plants. So this would just be one thing of plant. And then they don't know this, but they think fungi is a plant. It's its own category of life. And so we talk about that because they really don't know that. And then insects is its own thing too. And so if they get a rat, that's really only 3 things that they're putting down here. So you may want to say that you have to also do a rat and a bird or something like that. So you might say you have to at least do what's in your pellet and another prey on here so that they can get more practice with food webs. Okay, turning the page. Use the chart to calculate the biomass eaten. Transfer the last column of your data chart to the second column below. So I'm going to go to my data chart. I want this last column, mole and shrew here. Sorry. So this last column mole and shrew gets transferred up here to the second column. So 9, 10, and 9, 10. And now I'm going to multiply that number by the third column mass, then convert, and then multiply. So these are the directions. Some kids, they look at this and they're like, I don't know what to do. And you say, well, did you read the directions? And when they read the directions, most of them, 9 out of 10, get it. And then 1 out of 10, they still need some help, and that's okay. Okay, so let's clear. And so 9, 10 times 55, I'm going to get 50,050. And then 9, 10 times 5, so shrews weigh a lot less than a mole. I'm going to get 4550. Now, conversions. At this point of the year, I really haven't worked on metric conversions, so I tell them to divide by 1,000. You've got the kids who remember it from chemistry or physics or whatever class they had, so they're fine with this, but some kids need help. They haven't really done much with metric at this point in time in my class. You may have. So I tell them to divide, and then now they're going to take this, multiply by the food that they eat, the prey eats. So this is what the prey eats. So 50.05 times 365, I get 18,268. You can tell them to round. They don't have to put the decimals. And then I have 4.55 times 1168. And right now I want to give a shout out to Dr. E. Dr. E. Woltson is an APES teacher who's been around forever, and he created this lab many, many years ago. Okay, so now we're going to add these up. 18,268 plus 5314. So I have 23582, and this is kilograms. Oh, this didn't print very well, but there's 2 totals they need. So we also have to total up this as well. So they need this in kilograms and they need this in kilograms. Okay, so we're going to create a biomass pyramid. You need to tell them that it is a little bit, when we transfer like biomass to in this lab, we're assuming that this is going to be similar to an energy pyramid with calories and kcals. And so there's an assumption later on with this. Okay, so we're using this biomass pyramid, and this is where they need this number in the front right here, 0.8 kilograms. And then this number goes here, so 54.6 kilograms. And this number goes down here, 23,582 kilograms. Okay, and so this is mainly your produce. Well, doesn't really transfer that way because they're not all producers. So this is a little bit of a flaw in this lab, and you can talk with them a little bit because really it's going to be all your producers down here. And this really is the prey. They're not all producers. And this is the prey's food. And this is going to be the prey. And then this is going to be the owl. Now really we should split up our producers from the next level up. So we know this is a little bit flawed in that way. Okay, the pyramid above is a biomass pyramid. An energy pyramid usually, but not always, has similar proportions for the trophic levels of organisms. For our purposes today, we're going to use the number of the biomass to calculate energy loss. Again, they are different things, but we're going to assume that in this ecosystem, they have the same proportions. Okay, calculate how many times more energy is at the producer level, first trophic level, versus herbivore level. To calculate, divide the first trophic level So 23,582 kilograms by the second, 54.6 kilograms, and round. Show your work. So 23,582 divided by 54.6, and I'm going to round up to 432 times as much energy is on the first versus the second trophic level. How about second versus third trophic levels? So I'm going to do 54.6 kilograms divided by 0.8 kilograms. 54.6 divided by 0.8, and I'm going to get 68 times more energy at this trophic level. Okay, so now we're going to do percent loss. Now usually it's 10 times as much. So this is not 10 times as much because 10 is an average, and sometimes you lose a lot more, like in here we lose a lot more. Now this is a little bit more than what your students might see because with rats you don't have quite as much as this one, but you get kind of a lot. So all right, there's also some inaccuracies in here because it's also the size. We get a lot of baby rats, and so that's going to skew our results a little bit, but we can talk about the error. Right now we really want them just practicing and understanding trophic levels, and this is a great lab for them to understand energy loss and trophic levels. Now we're going to do percent change. The AP exam loves percent change. So how much energy lost from the first to the second? Okay, so we're going from the first, we're going to the second, so we're ending at the second. So we're ending at the second, so we're going to do our ending amount is the second, 54.6 minus 23,582 divided by 23,582 times 100. So in the calculator, I'm going to do 54.6 minus 23,582, and then I'm going to divide that by 23,582, and I'm going to round, and it's going to be a negative 99%. I'm not going to round because then it would round to 100. I'm not going to do that. So it's a 99% loss of energy. So it's a 90% loss on average. This one happens to be a 99% loss. Okay, what about going from the second to the third? So we're ending at 0.8. We started at 54.6 and we're divided by 54.6. I'm trying to get you in the sun. My shadows are moving as I'm outside. 0.8 minus 54.6 divided by 54.6, and I'm going to get about another, it's 98.5, so a little bit less, so negative. And you can have them put the decimal here, 99.7 I think that was, and this is 98.5. So again, still more than a 90% loss. You can talk about with birds, there's going to be a higher loss because they don't weigh very much because of their hollow bones, but they need a ton of food because they fly and their metabolisms are so high. So you're going to get more of an energy loss there. Okay. All right, so your textbook says that 90% of the energy is lost as you go up a trophic level. Are your results 90%? Why not? I just discussed that a little bit. So here are the questions that the students have referring to the first and second laws of thermodynamics. Energy is not really lost. It's transferred to heat, which is a form the ecosystem can't use. And so we say it's lost, but it's not really lost. But it's lost to the ecosystem, they can't use it. And then we have some prediction questions, cause and effect questions. So these are not only NGSS science and engineering practices, but they're also our AP science practice questions worked in here. Something you could change that would give you different results. That is definitely something that is an AP type question for the students. And then this is a standard lab conclusion that we do for our department. You feel free to do any kind of lab conclusion or write-up that you want for this lab. All right, so that's the owl pellet lab. Again, if your students somehow find my video that I just made right now and they come up with the same data as this, you know that it's not authentic because the likelihood of them finding one mole and one true is almost zero. All right, guys, have a great day.